how to calculate the inverse of a matrix. Now that you know how to calculate the determinant of a matrix, we can look at one of the main applications of determinants, which is to help find the inverse of a matrix. An n by n matrix, we'll call it matrix A, is invertible, meaning it has an inverse, if there exists a matrix, the inverse matrix of A, so that the inverse matrix of A times matrix A equals the identity matrix. And the formula for calculating the inverse of a matrix is as follows. To find the inverse of matrix A, you do 1 divided by the determinant of matrix A, and multiply that by what's called the adjugate, or sometimes the adjoint, of matrix A. And within this formula, there's a couple things to note. We know we can only calculate determinants for square matrices, so that means the only matrices that are invertible are square matrices. Also, the adjugate of matrix A is just equal to the transpose of the cofactor matrix of matrix A. And one other thing we should note is that if the determinant of the matrix was 0, we would have 1 over 0, which is undefined, which would mean that the matrix is not invertible. And we call that a singular matrix. And a determinant being 0, telling us that matrix A is not invertible, also actually tells us there's not a unique solution to this system of equations. But we'll get more into that in the next section. So let's go ahead and do an example where we use this formula to calculate the inverse of a matrix. Given this matrix A, let's find the inverse of matrix A. In this formula for the inverse, I need two things, the determinant of matrix A and the adjugate of matrix A. Let's start by finding the determinant. Since this is a 3 by 3 matrix, I know there's a shortcut for finding the determinant. I just rewrite the first two columns beside the matrix, and then find the sum of the product of these three diagonals. So this first diagonal is 4 times 5 times 3, which is 60, plus 2 times 2 times 2, which is 8, plus 1 times 3 times 1, which is 3. And then I subtract the products of these three diagonals. So I have to subtract 2 times 5 times 1, which is 10, 1 times 2 times 4 is 8, and 3 times 3 times 2 is 18. And if I simplify that expression, I get a determinant of 35. And now I need to find the adjugate of matrix A, which I know is equal to the transpose of the cofactor matrix of matrix A. So we'll start by finding the cofactor matrix of matrix A. I'm going to have to find the cofactor of all 9 elements of matrix A. Let's start with the element that's in row 1, column 1. To calculate its cofactor, I do negative 1 to the power of 1 plus 1. The exponent is always equal to the sum of the row and column indices of the element. And then that has to be multiplied by the minor of this element. And remember, the minor of an element is just the determinant of the submatrix we get when we eliminate the row and column that the element is in. So I now just have to find the determinant of that submatrix. So doing this calculation will give me the cofactor of 4, and to get the whole cofactor matrix, I have to do that calculation for all of the terms in the matrix. And now that I have all 9 terms of this matrix, I need to simplify each of them. So let's start with the element that's in row 1, column 1 of our cofactor matrix. Negative 1 to the power of 1 plus 1 is just 1, and then I need the determinant of this 2 by 2 matrix. And I know to find the determinant, let me zoom in a bit, I just have to do the product of that diagonal, 5 times 3 is 15, minus the product of this diagonal, 1 times 2 is 2. 15 minus 2 is 13. So I know the first element in my cofactor matrix is 13. And then I can repeat that process for the other 8 elements in this matrix. And I now have the cofactor matrix of matrix A. But what I need in my inverse formula is the adjugate of matrix A, which is the transpose of this cofactor matrix. So I have to transpose this matrix. The transpose of the cofactor matrix is the matrix that just has the rows and columns switched with each other. So row 1 of the cofactor matrix becomes column 1 of the transposed version of that matrix. And I'll do the same thing with row 2 becomes column 2 and row 3 becomes column 3. And now that I have the transpose of the cofactor matrix and the determinant, I can use this formula. I'll have to make a little bit of room, and then I'll sub into the formula. The inverse of matrix A equals 1 over 35. And since this value is not 0, since the determinant is not 0, I know that the matrix does have an inverse. So that means there is actually a unique solution to this system, which we'll get to in the next section of this video. And that has to be multiplied by the adjugate of matrix A, which is this transposed cofactor matrix. And then what we could do if we wanted to go further is we could multiply all 9 elements of this matrix by the scalar in front. And that would give me the following matrix. And there we have it. There's the inverse of matrix A.